entire digital electronics for competitive exam is based on this. Okay, you must need to do the minimization, and K-map gray code is going to play a very important role in your minimization part. Okay, so today I am going to discuss about the gray code and K-map, that is Karnaugh map. So all of you are ready, beta ji? Hello, hello. Please everyone, please write down in the comment section that all of you are ready. Please everyone, please write down in the comment section that all of you are ready, beta ji. All of you are ready? Let me verify that audio and video is coming. Okay, great. So audio video is okay? Great. Great. Yesterday we have completed logic gates, and in the logic gate only one part is remaining, that is your XNOR gate. That I will discuss at the end of the class. Okay, XNOR gate and the relation of 3 XNOR and 3 input XNOR and 3 input XOR gate. How we are going to take the approaches for the questions belonging for a 3 input XNOR gate. Is it okay? So that I am going to discuss. Okay. Also a very important topic, that is dual and self dual concept, and that also we will see. But first let's have a discussion onto the gray code and K map. Is it okay? Great, Sarji. Sir, how many subjects in this series are going to be covered for electrical, for electronics, for CS, for IT, and for ECE and instrumentation? Maximum subjects are going to be covered. Okay. Now please observe here. Write down first gray code. Please write down first gray code. So what is this gray code? Actually, just like a binary code, we have one language that we called as a binary code. We will write decimal 1 equivalent in binary 0 1. Is it okay? In the same way, decimal 2 number will be represented in binary code as 1 0. In the same way, we have one more code, and that code also have only 2 radix, that is only 2 base is only 2, but we will represent it a little bit differently. Now please observe, and that we called as a gray code. So please observe here. All of you are aware with a binary code now. In the first lecture already I have discussed and also tell you how to identify the decimal to binary and binary to decimal. Is it okay? Now please observe, in just I think in just 10 to 20 seconds I have discussed that, and hoping all of you have remembered. Suppose in binary code we have to write 0. What is the binary code of 0 in 2-bit? 0 0. Binary code of 1 in 2-bit is 0 1. Binary code of 2 in 1-bit 2-bit is 1 0, and binary code of 3 is 1 1. So if you observe 0 1, these two are the successive number. They will differ by 1 bit. However, 1 and 2 are successive number, but in this case 1 and 2 are successive number, but in this case it's differ by 2 bits. See, the LSB 1 here, the LSB is 0, MSB 0 here, the MSB is 1. So 2 bits are differing in the successive number. So it differs by 2 bit. In the same way, if you observe 2 and 3, so 2 and 3 will differ by only 1 bit. Is it okay? Yes, sir. So in binary code, successive number, just like 4, let us talk about 8, 7. What is 7 in 4-bit? 0, 1, 1, 1. What is 8? 8 in 4-bit is 1, 0, 0, 0. 7 and 8 are successive number, but they differ by 4-bit. What does it mean? It means, sir, in binary code, if we observe successive number, then bits can be differ by any number of bits. There is no fixed pattern. Is it okay? Yes, sir. If we talk about gray code, then gray code is a code in which each successive number will differ by only 1 bit. Is it okay? Now please observe here. If I want to write a gray code of 0, it will become 0, 0 in 2 bit. Gray code of 1, then it will become 0, 1. Gray code of 2 will be represented as 1, 1. And gray code of 3 will be represented as 1, 0. So in gray code, if you observe, each successive number will differ by only 1 bit. Each successive number will differ by only 1 bit. Each successive number will differ by only 1 bit. And if we talk about the largest number for 2 bit is 3, then 3 and 0 are also differ by only 1 bit. So that is why it is also called as a cyclic code. So in gray code, each successive number will differ by only 1 bit. Is it okay? Gray code is also called as unit distance code. Now I am hoping all of you able to understand why it is called as unit distance code, because each successive number will differ by only 1 bit. Also called as cyclic code or minimum error code. Basically, when we are designing a counters and all, at that time, if the flip-flops have to operate, it will come later on, but just listen carefully what I am saying. If we have a multiple flip-flops to operate, then there is a possibility that different flip-flops will have different propagation delays, and because of that there is a possibility of having some indeterminate states. However, if we talk about in case of gray code, then only 1 bit is going to change. So majorly we have to focus on that particular change of the flip-flop. Is it okay? So this reduces the error and also called as a minimum error, as only 1 bit is going to be changed in the next clock cycles. Is it okay? So gray code is also called as minimum error code or a unit distance code, or sometimes also called as reflective code. If you observe gray code, the major use of the gray code is for the simplification of logical expression. K-map uses gray code for simplification of logical expression. How many of you able to understand up to this part, Betaji? Okay, great. Sir, you didn't respond. What I didn't respond, Betaji? Neeraj, can you please tell me once again? What I haven't respond, Betaji? Can you please write down again once again? Neeraj? Okay. We will design this binary to gray code conversion circuit in the upcoming part of the lectures, but when we are going to discuss about the combinational circuit and the process to design combinational circuit. But for a moment, let us suppose I have designed a combinational circuit working as a binary to gray code converter circuit. Okay, so let's first discuss about 4-bit binary to gray code converter circuit. Please observe, Betaji. Always remember the MSBs of binary code and gray code will remain same. MSBs of binary code and gray code will remain same. Okay? Yes, sir. Then next significant bits are going to be XORed to have next significant bits of the gray code, and the process goes on till least significant bit. So we have B2, B1 and B0. In the same way we have G3, G2, G1, G0. For a moment, suppose I have a binary code and want a gray code of 7. Okay. So what is the binary code? What is the binary code of 7? 7 in binary code is 0, 1, 1, 1. What is 7 in gray code? Please observe, Betaji. This 0 will, as it is, comes here. Yes, sir. And we all know about XOR gate. XOR gate will give output logic 1 whenever the inputs are different. Is it okay? 0 otherwise. So here you can say 0, 1. 0, 1 is a different. When the inputs are different, this will become 1. If the inputs are same, this will become 0 because XOR gate is a inequality detector. Whenever unequal inputs are there, output is logic 1. For equal, output is logic 0. B1 and B0 both are 1, so this will become 0. So 7 in gray code. 7 in gray code. How many of you can see this 7 in binary code and 7 in gray code? Please observe once again for 8 in binary code or 8 in gray code. For a moment, please observe this pink line. Okay. Yes, sir. Only focus on the pink part. Okay. Now, if we have 8 in gray code, then it will be 1, 0, 0, 0. Yes, sir. What is 8 in gray code? 8 in gray code. This MSB1 will come as it is. Yes, sir. For different input, B3 and B2 are different. So XOR will become logic level 1. Same. So XOR will become 0. Same. So XOR will become B1 and B0. So 8 in gray code is 1100. 7 in gray code is 0100. 7 and 8. 7 in gray code is 0100. 8 in gray code is 1100. These two will differ by only 1 bit. They are successive number and differ by only 1 bit. However, in binary code, they will differ by 4 bit. But here, they will differ by only 1 bit. How many of you able to understand how to find out a gray code for the given binary code? Is it okay now, Betaji? Sir, it's showing invalid ID. Sir, the class note link doesn't able to open previous, huh? How is it possible? I have shared on my Telegram as well. Betaji, I have shared that on my Telegram as well. And I have opened many times. Maybe you can first check your phone memory and then try. It will open, okay? Now, please observe reverse of this. If we want to do the conversion from gray code to binary code, okay? So 4-bit gray to binary code conversion circuit. If we talk about 4-bit gray to binary code conversion circuit, okay, 4-bit gray to binary code conversion circuit, okay. If we talk about 4-bit gray to binary code conversion circuit, then please observe the MSBs of gray code and binary code will remain same, G3, G2, G1, G0, and we want to convert it into B3, B2, B1, B0. Now please observe the MSBs will remain same. MSBs will remain same. Now the output binary and next input gray code are being XORed to have next binary bit. The same process goes on. The same process goes on till least significant binary bit. Is it okay? We will see the method also how we have designed this. This is a basic combinational circuit. Any combinational circuit can be designed in just 4 steps. So that we will see while studying the combinational circuits. Is it okay? So let's have a conversion for 8. What is 8 in gray code? We have observed 8 in gray code is 1, 1, 0, 0. Let's talk about 8 in gray code and I want to convert it into binary code. So 1 B3 will remain same as it is G3. MSBs are same. However, this one and this one, whenever the two inputs, whenever these two are the inputs, B3 and G2. So B3 and G2, whenever they are same, output is a 0. Whenever they are different, output is 1. So B2 and G1, 0, 0, same, so output is 0. B1 and G0, 0, 0, so B0 will remain 0 only. So now we have 8 in binary code. How many of you able to understand how to do the conversion from binary to gray and gray to binary, Betaji? Can you find? How many of you able to understand, Betaji? Is it okay now? Great. Now let's talk about question. Find gray code of the given binary code. So binary code is given to you as 1 1 0 1 0 0 1 0 1. Can you find out the gray code, Betaji? It's very easy, sir. It's very easy, sir. The gray code will have most significant bit remains same. Then for next we have to do the XORs. Next bits we have to do the XOR. You can just copy the MSB and then observe the MSB and next bit XOR to have the next bit of gray code. The same goes on. How many of you able to understand the conversion of binary to gray code? Please let me know by writing in the comment section, Betaji. So please observe this one as it is. For same, XOR gate is available with the two inputs only and the output is high whenever the inputs are different. So here for same we get 0, for different we get 1, for different we get 1, for different we get 1, for same we get 0, for different we get 1, for different we get 1, for different we get 1. So this is the gray code of the given binary code. Let's do the reversal to identify whether we have made a correct gray code or not. Okay. Yes, sir. So let's do the reversal. So I just wanted to recheck whether we are able to retrieve the binary code once again from the given gray code. So please observe this MSB will as it is. Now the MSB and next significant bit, the gray code and binary code obtained are being XORed. The gray code and binary code are being XORed. How many of you able to understand? Please let me know, Betaji. So if you observe here, we have 1. This 1 and 0 different, we will get 1. 1 1 same, we will get 0. Different, we will get 1. Same, we will get 0. Same, we will get 0. Different, we will get 1. Same, we will get 0. Different, we will get 1. So yes, sir, we have retrieved the same binary code. So now you can easily do the conversion from given binary code to gray code or from given gray code to binary code. How many of you now able to understand, Betaji? QR for the Telegram. Okay, okay. Yes, you are asking for the right thing. At the end of the class, I will just show the QR code. Okay. It is there only, but I have to put it in front of the. So at the end of the class, I will show. How many of you able to understand up to this part, Betaji? Great. So now we know about the conversion of gray to binary code and binary to gray code. Also able to understand the basic gray code. Is it okay? Yes, sir. Now please observe 𝐂𝐚ap. Now please observe 𝐂𝐚ap. Why we are using 𝐂𝐚ap? 𝐂𝐚ap is used for minimization of logical expressions, and it is useful when number of variables are up to 3 only. So if we talk about digital circuits and its problem need to be solved by using minimum variables or minimized expressions, is it okay? That reduces the cost and increases the speed. 𝐂𝐚ap is an approach to minimize the Boolean expression consisting minimum variables without using any Boolean theorems. Okay, it can take both SOP and POS it is a table representation. It is a table representation of variable. Now, very important point that you have to remember for a K-map is K-map uses gray code and used for minimization of logical expression when number of variables are up to 5 and output may be 0 or 1. Output may be 0 or 1. Okay. So K-map uses gray code and used for minimization of logical expression when number of variables are up to 5. It is useful up to 5 variables. You can use it for more as well, but we will use up to 5 variables. Okay. However, I will show you how to solve the questions of up to 6 variables as well. Okay. And output may be 0 or 0, 1 or don't care. 0, 1 or don't care. 0, 1 or don't care. Don't care will be represented by a cross symbol. Okay, don't care will be represented by a cross symbol. Great, sir. Now, please observe here. Before moving to the minimization through K-map, let's try to understand how the representation of the K-map will be. So, we have two representation for the K-map. One is your SOP, another one is your POS. Let's first talk about SOP. So, in SOP, first for two variables. If we have two variables, let us suppose the variables are A and B, then how to represent a K-map? K-map will be representing all the possibilities of the two variables in square boxes. So basically, if we have a variable A and B, how many possibility? Either both are low, any one of them is high, or both are high. So it shows all the possibility. It will be represented here as MSB will be kept here as A bar A, and here we have, or you can just write like this. You can just write like this. We have A and B. MSB A I have kept on the left side and LSB on the right side. Is it okay? Now please observe, K-map uses gray code. Okay. So in the sub block we have to write all the possibilities. Here we have a 0 0. 0 0 means 0 0. It can be represented here as 0 0. 0 0 is the gray code of 0. Then we have 0 1. 0 1 is the gray code of 0 1 is the gray code of 1. Is it okay? Yes, sir. And then we have 1 1. 1 1 is basically gray code of 2 and 1 0 is gray code of 3. So if you observe in gray code, this is 1 2 0 1 2 3. 0 1 2 3 in gray code. In gray code it is 0 1 2 3. However, whatever function we want to do the minimize, that function will always be in the that function will be in the form of binary code. Okay, so we do the numbering as per the binary. So as per the binary, all of you can now observe this 0 0 is the binary of 0, 0 1 is the binary of 1, 0 1 1 1 is the binary of 3, and 0 1 1 0 is the binary of 2. In gray code it is 0 1 2 3. Is it okay? However, in binary code it is 0 0 is the binary of 0, 0 1 is the binary of 1, 1 1 is the binary of 3, and 1 0 is the binary of 2. Is it okay? Since this is a SOP, so in SOP, 0 is represented by variable complement and 1 is represented by variable. 0 is represented by variable complement and 1 is represented by variable. So basically each subblock is representing one minterm, and the minterm of this is A bar B bar. We all know about the minterm of 0 in terms of AB. This is A bar B bar. In the same way, this block is representing A bar B. This block is representing AB. This block is representing minterm A, B bar. Is it okay? Yes, sir. Now we have two variables. In the same way, if I talk about three variables, second, let's talk about three variables. Okay. So if we talk about three variables, then for three variables, we have total 8 possibilities that can be represented from binary of 0 to binary of 7. Let me use the MSB A and LSB C. Okay. Yes, sir. So total number of possibilities with the three variables are 8. So 8 subblocks are there, can be represented by 2 cross 4. Here we have a 0 and 1. Okay, this will be your 0, 0. 0, 0, 0 is the binary gray code of 0. 0, 1, 0, 0, 1 is the gray code of 0, 0, 1 is the gray code of 2, gray code of 1. 0, 0, 1 is the gray code of 1. 0, 1, 1 is the gray code of 2. 0, 1, 0 is the gray code of 3. So in gray code it is 0, 1, 2, 3. In the same way 4, 5, 6, 7. So 0, 1, 2, 3, 4, 5, 6, 7 is in the gray code format. But whatever function we have to minimize, mostly the function is in the binary code. So we do the numbering as per the binary code. So here we have 0, 0, 0, 1 is the binary of 1, 0, 1, 1 is the binary of 3, 0, 1, 0 is the binary of 2. So this numbering jumble is because the blocks are arranged in gray code, but the function which we want to minimize mostly is in the binary form. So that is why we are doing the numbering as per the binary. Okay. Here we have, sir, 4, 5, 6 and 7. How many of you now able to understand? Please let me know. If we have to represent in terms of variables, so 0 is represented by variable complement. In case of SOP, 1 is represented by variable. Here we have B bar plus C bar. This 0, 0 means B bar plus C bar. Here we have B bar plus C, B bar C, BC and BC bar. How many of you able to understand this representation, beta ji? Let's talk about 4 variable as well. If we have for 4 variables, then total number of possible combination will be 16. So for 16 combination, we have to make the 16 subblocks that can be represented by 4 cross 4. Let us suppose we have the variables A, B, C, D. So A is a MSB and D is a LSB. Okay. Now in gray code, we have to write 0, 0, 0, 1, 1, 1, 1, 0. This is in gray code 0, 0, 0, 1, 1, 1, 1, 0. So it is represented in gray code 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and so on. But actually the numbering need to be do in terms of binary code. So this is your 0, 1, 2, 3, 4, 5, 6, 7, 7, 0, 1, 1, 1. So this subblock is representing 7. 0, 1 is from this and 1, 1 is from this. Okay. In the same way, this is your 8, 9, 10, 11, 12, 13, 14 and 15. So very important. Please observe here, we have in terms of variable A bar, B bar. From here, A bar, B. So I am writing just for 0 we have A bar, for 0 we have B bar, for 0 we have A bar, for 1 we have B, for 1 we have A, for 1 we have A, B bar. In the same way, if you observe here C bar, D bar, C bar, D, CD, CD bar. Hoping all of you able to understand the representation now. Great. All of you able to understand the representation now? Great. So this is your SOP representation. Let's talk about POS representation as well. Let's talk about POS representation as well. So I have here SOP, and on the next page I am just doing a small modification for POS. Okay. I am just doing the small modification for POS. Okay. Yes, sir. Now please observe, First, we have seen SOP. This is a SOP. SOP representation of 2 variable, 3 variable, 4 variable. Now for 5 variable, we have 2 representation of 4 cross 4, 4 cross 4 K map. In the same way, for 6 variable, we have 4 cross 4 K map, and so on. Now please observe here. For POS representation, 2 cross 2, all sub blocks and everything will remain same. Only the sub blocks now representing max term instead of min term. So if we have AB, for max term 0 is represented by variable and 1 is represented by variable complement. This will be represented, 0 is represented by variable and 1 is represented by variable complement. In the same way, if we have ABC, then this will be your A bar, and here we have a max term. So B plus C. 0 means B plus C. Here we have B plus C bar. Here we have B bar plus C bar. Here we have B bar plus C. So actually, if you observe, what is the max term of 3? We all know in terms of ABC, max term of 3 is A plus B bar plus C bar. So every block is representing a sum term in POS form. In POS form, the same block is now started representing sum term. Is it okay? So in a same K map, you can see SOP as well as POS. But the important is whether you are observing the min term or a max term. Is it okay? Great, sir. In the same way, for 4 variables, we have 0, 0, 0, 1, 1, 1 and 1, 0, 0, 0, 0, 1, 1, 1 and 1, 0. So in POS, each sub block is representing max term. So we will represent A plus B bar, A bar plus B bar, A bar plus B. Is it okay? Already I have discussed about POS. Great. So in POS, each sub term is a addition term. Is it okay? Yes, sir. And that addition term must give logic 0. Okay, so we have now here C bar plus C plus D, C plus D, C plus D bar, C bar plus D bar, and C bar plus D. Suppose if you have to write the max term of 15. So how you will write max term of 15? A bar, B bar, C bar, D bar. So this is representing this particular sub block. Is it okay? Yes, sir. So now we know about the representation, SOP as well as POS. Hoping all of you now able to understand SOP and POS representation. Okay, great. We'll discuss why this representation is, because the sub blocks are in gray code. Sub blocks are in gray code. Is it okay? So that the numbering is different as per the binary code. Hoping all of you able to understand. Great, sir. Now, please observe first thing, the order of preferences that we have to follow. Some terms are very important, that are prime implicant, essential prime implicant, implicant, prime implicant, essential prime implicant. These 3 words are very important to solve any question in K-map. Is it okay? But before going to that, just let's try to understand what are they. Okay. So first, order of preferences. Write down order of preferences. What is order of preferences? Order of preferences, first is your octet. Octet means 8 continuous subshells are filled. Those subshells are said to be continuous subshells. Those subshells are said to be continuous subshells which shares either this boundary or this boundary. Either this boundary or this boundary. Is it okay? Yes, sir. So here, suppose if we have a logic level presented onto the binary condition of 1, 5, 13, 9, 11, 15, 7, then these are sub block. These are adjacent sub blocks. Is it okay? So if they are filled with logic level 1, we can make a pair of, we can make a octet grouping first. Is it okay? Yes, sir. So octet has the highest preference among all, okay, for up to 4 variables. Order of preferences, octet. Largest group will have the highest preference. Largest possible grouping for 4 variables. Is it okay? Yes, sir. Now octet has the highest preference. An octet eliminate three variables. An octet eliminates three variables. Please write down, beta ji. First preference is given to an octet. An octet eliminates three variables. First preference is given to an octet. An octet eliminates three variables. Is it okay, beta ji? Yes, sir. Now please observe chord. Chord means four ones. A grouping of 4 ones is called a chord. Suppose we have these 4s are filled with logic level 1. So they are adjacent subblocks. If they are filled with logic level 1s, then we can make a chord. Is it okay? So chord will have the second preference. Chord will have the second preference. Second preference is given to chord, and it eliminates two variables. If we have total 3 variables, 4 variables, then 2 variables get eliminated by the chord. Third preference is given to pair. Pair means any 2 adjacent subcells are filled. It can be filled by logic level 0s for POS and logic level 1s for SOP. Okay. So third preference is given to pair. Pair means 2 variables, 2 adjacent subblocks are filled. It eliminates one variable. It eliminates one variable. And the last preference is given to alone. If required. Alone means it is neither making any group or any pair. Is it okay? So now you know about the preferences. Now you know about the preferences. Is it okay? Yes, sir. Let's try to understand these preferences with one question. Okay, that will help you to understand the topic in a more better way. Then we will come back to the implicants and all other things. Please observe the first one. Hoping all of you now able to understand the representation of K-map, SOP as well as POS, and the order of preferences all of you have made in your notes. Okay, done? Okay, great. Now please observe, if a function is defined as summation of m 1, 2, 3, the minimum the minimized expression will be. So you have to identify the minimized expression. Now please observe, beta ji. Now please observe, it's very simple. This class is very important. If you are doing this class, you will be able to solve almost every question directly. Need not to go with any kind of Boolean algebra and all. Okay. Now please observe here, we have a function of 2 variables, a function of 3 variables. So 3 variables, 1, 2, the largest number is 3, and we have 2 variables. Function is of 2 variables. So first draw a K map of 2 cross 2. Okay. So we have a 0, 1, and here we have a 0, 1. We all know about the numberings. 0, 1, 2, 3. Yes, sir. These are the subblocks representing a specific binary, that is 1, 1 is represented by this 3. Okay. Now A bar, because SOP, this is in SOP, summation of min term is a representation of SOP. Yes, sir. We have A, B bar and B. Now please observe, SOP is used for output logic 1. SOP is used for output logic 1. SOP is used for output logic 1. Basically, you have represented the function A, B, F. So basically you have represented a function 0, 0, 0, 1, 1, 0, 1, 1. Here we have represented a function as 1, 1, 1. So onto the binary of 1, onto the binary of 2, and onto the binary of 3, we are getting output logic level high. SOP is used for output logic level high. So this is what the function is representing. Your function f of a comma b is summation of m 1 2 3. It means onto the binary condition of 1, onto the binary condition of 2, and onto the binary condition of 3, we are getting output high. Is it okay? Yes, sir. Now, so what are the positions where we are getting output binary high? 1, 2, and 3. Now, please observe, beta ji. Now, please observe, beta ji. 1 and 3, 1 and 3. This is not 1 and 3. Actually, in gray code, this is the gray code of 0, gray code of 1, gray code of 2, and gray code of 3. So in gray code, each successive number will differ by only 1 bit. If you observe these two, they will differ by only 1 bit. What does it means? Sir, here we have, if we observe here, we have a bar for this min term is a bar b. This is a min term also called as implicant. And this is a min term AB. AB is also a min term. Is it okay? So if you observe these two, which I am shading with the orange color. So we have a bar b and AB. They will differ by only 1 bit. So when they will differ by only 1 bit, and if we take b common, what it becomes? A plus a bar, and what it become? B only. So it indicates best to have a common in this pair. As per the preferences, first preference is given to octet, which is not possible in 2 variables. Chord, not forming any chord. Then third preference is pair. If you observe, this is forming a pair because they are sharing the boundary. Is it okay? These two will differ by only 1 bit. If these two will differ by only 1 bit, we can have the common. What is common in their minterms? Common in their minterms is b only. Common in their minterm is b only. So I can write directly. This pair will give b plus. Is there one more pair possible? Yes, sir. When pair is forming, create a pair instead of going with alone, because K-map always gives the minimized expression. So what we are getting? B plus A, or someone can write A plus B, because OR gate follows both commutative and associative law. So it follows commutative law. You can write B plus A or A plus B, both are the same thing. How many of you now able to understand this? Great. In the same, you have to write one more very important point. Please observe. K-map is joint from top to bottom and front to back. Now what does it mean? Let me explain with the help of one question. Okay, so K-map is joined from top to bottom and front to back. We will consider this line along with the preferences. Please observe, beta ji. Now one very important term is implicant. What is implicant? If you are writing this min term, always a min term, implicant, prime implicant, essential prime implicant, all are only for the min terms. Okay, if you observe this, what is the min term of this? A bar B. A bar B is a implicant. What is this? AB. AB is a implicant. What is this? This A B bar. A B bar is also a implicant. So wherever we are getting a logic level 1, okay, so that product term is simply said to be implicant. Is it okay? Now come to the prime implicant. Prime implicant, those pair, chords or octates which cannot be further minimized. The product term obtained from the K-map, in short, the product term obtained from the K-map which cannot be further minimized is said to be prime implicant. So if you observe, we have one pair. Now this pair cannot be further minimized. Is it okay? So this will become prime implicant. In the same way, this A is a product term obtained from the K-map which cannot be further minimized. So this will become prime implicant. All prime implicants are implicants. Is it okay? So these two are implicants as well. but they are prime implicants. The product term obtained from the K-map which cannot be further minimized. Is it okay? So till now we know about the implicants and prime implicants. Hoping all of you able to understand up to this part. Great. Let's have one more question to understand it in a more better way. Suppose we have a function f of a, b, c as summation of m 0 to 4, 0 to 4, 6, 0 to 4, 5, 6, 0 to 4, 0 to 4, 7, 0 to 4, 6, 7, 0 to 4, 6, 7. Suppose we have a function 0, 4, 0 to 4, 6, 7. We have to find the minimized expression of the function f of a, b, c. So now we are able to understand with a, b, c how many possibility? Sir, total 8 possibility, which will be represented from binary of 0 to binary of 7. Is it okay? Yes, sir. So for 8 possibilities, we have to draw the K-map of 2 cross 4. For 3 variables, we have to draw the K-map for 2 cross 4. Yes, sir. K-map always gives the minimized expression. K-map always gives the minimized expression. Now, please observe here. We have a bar a because of 0 and 1. Here we have 0, 0, which will be represented as b bar c bar, 0, 1, b bar c, 0, 1, 1, b c, and 1, 0, b c bar. 0 is indicated with a bar and 1 is indicated with a. Now, please observe the numbering 0, 1, 2, 3, 4, 5, 6, 7. Each block is representing a minterm. Is it okay? What are the binary conditions where we are getting output logic 1? Onto the binary condition of 0, onto the binary condition of 2, onto the binary condition of 6, and onto the binary condition of 7, onto the binary condition of 4, we are getting logic level 1. Is it okay? Yes, sir. Now please observe the line that K-map is joint from top to bottom and front to back. What does it means? Actually, these two will differ by only 1 bit, top to bottom, and these two boundaries are also shared. It means gray code of, actually it is in gray code 0, 1, 2, 3. So gray code of 3 and gray code of 0 are also differ by only 1 bit because it is a cyclic code. So what does it indicate? It indicates these 4 numbers, these 4 subblocks are also adjacent subblocks. Basically, they are sharing this boundary. So these 4 subblocks are also adjacent subblocks. So if they are adjacent subblocks, then a chord will have higher preference than a pair. So instead of forming a pair, we will give first preference to chord. That is a grouping of 4. So what is common in minterms of all these 4? If you observe what is in this minterm, a bar, b bar, c bar. In this a bar, b, c bar. In this a, b bar, c bar. In this a, b, c bar. So you can observe here that c bar is common in all of the minterms. So c bar is common in all of the minterm, and a chord eliminates 2 variables. Total we have a, b, c, 3 variables. So 2 variables get eliminated. So it means a chord will give only c bar. How many of you now able to understand, Bitaji? Out of a, b, c, we have only c bar, only 1 variable. 2 variables get eliminated by the chord. In this minterm, in this minterm, in this minterm, in this minterm, all of the minterms, only c bar is common. Is it okay? Yes, sir. Now please observe. Any other pair, any other chord is possible? No. Any other pair possible? Yes. If the pair is possible, then pair preference is higher comparative to alone. So you must have to take this pair. Okay. Instead of taking pair, if someone taken this alone, then the answer will be wrong, because K-map always gives the minimized expression. So with this pair, what is common? A from here and B from here. So A, B. How many of you able to understand the minimized expression of the given function? How many of you able to understand the minimized expression of the given function, Betaji? Great, sir. How many of you able to understand the minimized expression of the given function, beta ji? Great, sir. So this is what we called prime implicant. This is what we called prime implicant. And if each of the logic ones you will observe, they are implicant. All the prime implicants are also implicants. Is it okay? Sir, why A is 0, not 1? A is 0. A bar. A bar, 0 is A bar and 1 is indicated by A. Beta ji, we have a min terms. See, basically, if we have three variables, na, please observe beta. I am explaining it once again because some of you are just from first year or second year. So allow me to explain it once again. A, B, C and output function F. So how we will represent the binary conditions for a 3 inputs? How many possibility? Either all are low, any one of them is high, or any two of them are high, or all are high. So total 8 possibilities which will be indicated in terms of binary of 0, binary of 1, 2, 3, 4, 5, 6. Okay, I have missed 4. No issue. 1, 0, 0, 1, 0, 1 and 1, 1, 0 and 1, 1, 1. So total 8 possibility. That is binary of 0, binary of 1, binary of 2, 3, 4, 5, 6, 7. So we have 0 to 7, that is total 8 possibility. Is it okay? Yes, sir. Now each will have a min term. If you observe what is the min term, what is the min term for 0? Min term for 0 in terms of ABC is A bar, B bar, C bar. So here this subblock is representing a min term of 0. 0, 0, 0 is representing the min term of A bar, B bar, C bar. In the same way, min term of 1, 0, 0, 1, A bar, B bar, C. So this is A bar, B bar, C. In the same way, we have subblocks. Is it okay? And if we have logic level ones, it means min terms are present here in the function. We are getting the function high onto the binary of 0, onto the binary of 0, onto the binary of 2, 4 and 7. So we are getting these min terms, means we have a function having A bar, B bar, C bar, A bar, B bar, C, A bar, B, C bar, A, B bar, C bar and A, B, C. So actually we have this function. We want to do the minimization of this function. Is it okay? So here we have logic level 1s present. K map is in gray code. So we all know gray code differ by only one bit. So by pairing, octating or coding, we can eliminate the variables and minimize our function. So basically if you observe here, your 0, 4, 2 and 6. 0, 4, 2 and 6 gray code will be differ by only one bit and they can form a chord. So because of that we have a 0, 2, 4, 6. 0, 2, 4, 6 is also there. 6 is also there. A bar, A, B bars, A, B, C bar. So if you observe here, in the min term of 6 we have C bar. In the min term of 4 we have C bar. In the min term of 2 we have C bar. And in the min term of 0 we have C bar. So which particular term is common to all the min terms in the chord, pair or octate, that we will consider as a minimized expression for this. Is it okay now? Great, sir. Please let me know by writing in the comment section, beta ji. Hoping now all of you able to understand. Please let me know by writing in the comment section, beta ji. Great. Now please observe once again. Please observe once again. One more question. Suppose we have a function. We have to find the minimized expression for the function shown below. Okay. So find minimized expression. Please observe for function shown below. Okay. See, suppose we have a function A, B, C, D. and the function is summation of m 0 1 0 1 2 4 5 6 8 9 10 11 12 13 14 and 15. Suppose we have a function this. We want to find the minimized expression for the function in which we are getting output logic 1 onto the binary condition of 0 1 2 4 5 6 7 8 10 and so on. So first of all we have a 4 variable, so draw a 4 variable k map. Yes sir. So a 4 variable k map means total 16 subblocks. Each subblock is representing a minterm. Here MSB I am considering A, so AB onto the MSB side and CD. Is it okay? So we have 0 0 0 1 1 0 1 1 and 1 0 in gray code. All the subblocks are in gray code. 0 0 0 1 1 0 1 1 and 1 0. Is it okay? It is in this way: 0 1 2 3 4 5 6 7 8 9 10 11 and so on. So it's in a gray code. Is it okay? But the function which we want to do the minimization, it is indicated in the binary form. So we must have to do the binary numberings. As per the binary numbering, you can observe 0 0 0 0 is the binary of 0. 0 0 0 1 is the binary of 1. 0 0 1 1 is the binary of 3. 0 0 1 0 is the binary of 2. In the same way, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. What are the outputs where we are getting output? What are the numbers where we are getting output logic 1? Or we are getting output logic 1 on 0, 1, 2, 4, 5 and 6, 8, 9 and 10, 12, 13, 14 and 15. So first is we have to observe, is there any octet possible? If an octet is possible, the first preference is given to an octet. Octet means 8 continuous subshells are filled. So you can observe here 8 continuous subshells are filled. Please observe 8 continuous subshells are filled. So first preference is given to an octet. What is common in all of the minterms? What is common in all of the minterms? See, it is not possible to have common here from here. If we represent this A bar, B bar, A bar, B, A, B, A, B bar, C bar, D bar, C bar, D, C, D, C, D bar. It is not possible to have anything common. It is not possible to have anything common from this side. Only one term is common for all of these 8 conditions, and that is C bar. So C bar is in all of the minterms. So minimized expression obtained by this octet is C bar. Is it okay? Sir, we have 11. 11 is also in the question. Okay. 11 is also in the question. Okay. 11 is also in the question. Great. 11 is also in the question. Please do that 11 also. So 11 also high. 11 is also high. Okay. 11 is also high. Is there any other octet possible? Yes, sir. Another octet is also possible. These are 8 continuous subshells. So with these 8 continuous subshells, what is common for all? What is the minterm for all of them? Sir, B, A. So we have A by this octet. Is there any other octet is possible? Someone is saying, sir, chord is possible. The higher preference is of octet. So if octet is forming, you must have to create an octet. Is it okay? Yes, sir. So we all know that K-map is joined from top to bottom and front to back. So since the word front to back, it indicates we have one more octet possible if you observe the subblocks 0, 2, 4, 6, 12, 0, 2, 4, 6, 12, 8, 14, 10. Then an octet is possible. And what is common for this octet? Here we have C bar, D bar, here we have D bar. So D bar is common. So one can say, sir, we have the minimized expression of the given function as a c bar d bar. How many of you now able to understand the concept of chord, octet and pair? How many of you now able to understand the concept of chord, octet and pair now? All of you able to understand up to this part? Great, sir. Now, please observe, it's a very simple thing. How many of you now able to understand? Please let me know by writing in the comment section, Betaji. But such a small things are not going to be asked in GATE or ECE. Okay. So they will ask something more complex part from this. So let's talk about that. How many of you able to understand up to this part? Great. Now please observe. Now please observe. Now please observe. Now please observe one very important thing. Before moving to the cases, one very important thing. A note point where you can mention the term, definition and key feature. Just listen very carefully. It is very easy to understand. So the first term is implicant. Already we have seen what is implicant means. The minimized, unminimized, if we talk about min terms, all the min terms are implicant. All the prime implicants are implicants and all the essential prime implicants are also implicants only. Okay. So we have a min term, implicant first. Any term that covers one or more min term is called implicant. Key feature can be further simplified. A min term which can further simplified comes in the category of implicant. Implicants, any min term, single or covering more than one min term is your implicant, which can be further minimized. Those grouping of logic level ones which cannot be further grouped, or you can say which cannot be further minimized, or you can simply say the product term obtained from the K map which cannot be further minimized is your prime implicant. The product term for logic level 1, I am saying the product term obtained from the K map which cannot be further minimized is your prime implicant. Is it okay? And we have a term called essential prime implicant. Essential prime implicant is a prime implicant that contains at least one min term which is not the part of any other prime implicant. In short, that prime implicant which contains at least one logic level 1 which is not the part of any other prime implicant. Is it okay? That is what we called essential prime implicant. Any minimized expression must have essential prime implicant. All essential prime implicant, some prime implicant, is it okay? And none implicants, some prime implicants and some non-essential prime implicants as well. Any minimized expression will have all essential prime implicant, may have some non-essential prime implicant as well. Okay. Now let's come back to the understanding of this particular thing with the help of one question. This is a special case as well. So call it as case 1. Please observe everyone. Find the minimized expression for the function f of a b c as summation of m f of a b c summation of m 0 1 0 1 3 6 7 0 1 3 6 7. Suppose we have a function summation of m 0 1 3 6 7. So how to solve this? Now please observe beta ji. How to solve this? Now please observe beta ji. We have to use a K map of 2 cross 4 to solve this. Yes sir. Now please observe. We have A bar A, B bar, C bar, B bar, C, B C, B C bar. All of you are knowing about the numberings as well. 0, 1, 2, 3, 4, 5, 6, 7. This is a SOP expression. Yes, sir. So now you can please observe we have a logic level 1 presented here. We have a logic level 1 presented here, 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 and here. Is it okay? Yes, sir. Is there any chord forming? No. There is no chord. Okay, there is no chord. Is there any chord? No. Is there any pair possible? Yes, sir, the pair is possible. So can you please tell me what are the possible pairs? Can you please tell me what are the possible pairs? Please write in the comment section, Bitaji, and tell me what are the possible pairs. Please tell me in the comment section what are the possible pairs. I am asking from everyone. So sir, 0 and 1 is a possible pair. Okay, 0 and 1 is a possible pair. Let me take that pair. Okay, 0 and 1 is a possible pair. What else? Sir, we have 6 and 7 is a possible pair. Okay, what it gives? Sir, with this pair we will get A bar, and from here we have B bar. Plus in this pair the min term will have A, and from here we have B. So AB. Is it okay? Yes, sir. Any other pair is possible? Can you please tell me? 3 and 7. Someone is saying, sir, one pair is possible, 3 and 7. Okay, let's have a 3 and 7 pair. Someone is saying, sir, can you take this as a pair? Okay, let's take this pair. So this will give you BC. Someone is saying, sir, we can take this pair. Okay. Again, please observe. We have A bar, B bar, A bar, B. Someone is saying, sir, instead of taking this green pair, why not to take, instead of taking this green pair, why not to take this 1 and 3 pair? Instead of taking this green pair, why you haven't taken this 1 and 3 as a pair? If I take 1 and 3 as a pair, then your answer will be A bar, B bar plus AB plus of A bar, C. Is it okay? Someone is saying, sir, forget about it. Convert it into the equivalent POS. So if we have a SOP, can we write POS? Yes, sir. Onto the binary condition of 0, 1, 3, 6, 7, we have logic level 1. So rest of the places we have logic level 0. Yes, sir. So 0, 1, 2, 3, 4, 5, we have logic level 0. So if we have logic level 0, why not to go with POS form? Let's go with the POS form. In POS, POS is used for output logic 0. POS is used for output logic 0. Yes, sir. So if POS is used for output logic 0, and we all know POS, each subblock is representing max term. Each subblock is representing max term. So we have A bar, B bar, B plus C, B plus C bar, B bar plus C bar, B bar plus C. So someone is saying, sir, 0, 1, 2, 3, 4, 5, 6, 7. Now, what are the conditions where we are getting output logic 0? So we are getting output logic 0 on binary of 2, binary of 4, and binary of 5. So for POS, we have one pair and one alone. So if we have one pair and one alone, what will be your answer? The minimized expression for the function will become, sir, from here we have A bar plus from here we have B common. Okay, B is common for both of them. And for this we have, sir, alone. So we have A plus of B bar plus C. Is it okay? In POS, each is some term. Okay. Yes, sir. So you said, sir, you have to write it in the equivalent SOP. So convert it into SOP. So A into A bar, when you open this bracket, A into A bar will become 0. So A bar, B bar we are getting. A bar, B bar we are getting. And A bar, C we are getting. AB we are getting. And AB and BC we are getting. So someone is saying, sir, instead of writing this, it is better to go with POS. If you will go with POS, your answer would become A bar B bar plus of AB plus of BC plus of A bar C. Is it okay? Yes, sir. So which among them is correct? I am creating one more option, both A and B. Both A and B. So which one is correct? Now the concept of essential prime implicant came into the picture. Is it okay? Yes, sir. Now please observe, this is very important. Now the essential prime implicant will come into the picture. And one more thing you have to remember. K-map always gives the minimized expression, but the expression may or may not be unique. Or sir, that means we can't solve the question by using Boolean algebra. Yes, if 3 or more than 3 variables, it would be far better to keep away yourself from the Boolean algebra, because K-map gives the minimized expression, and the minimized expression may or may not be unique. It means more than one answer is possible. Is it okay? But it always gives the minimized expression. That is truth. So K-map always gives the minimized expression, but the expression may or may not be unique. The expression is unique when all are essential prime implicants, and it becomes more than one solution is possible if we are using some essential and some non-essential prime implicant. So here option number D is correct. Both A and B are right. Please observe how to observe the essential prime implicant. In essential prime implicant, to find essential prime implicant, first of all try to identify those logic level ones which are some odd positions. Okay, and they can be the part. There is only one way to minimize that particular minterm. See, when I saw this, first of all, when you saw this, how to approach such kind of questions to have a correct answer. Please observe, beta ji. First of all, you have to identify the essential prime implicant. How to find essential prime implicant? Find those pair, chord or octates which can be drawn in only one way. And it is essential to make that pair, chord or octate. Is it okay? So that grouping which can be done in only one way, and it is essential to make the grouping, that will give you essential prime implicant. Please observe here. I found this logic level 1 here. It can be minimized in only one way, to have this pair. However, if someone is observing this, then it can be minimized either by this pair or by this pair. So this will not give essential prime implicant. This logic level at 1 can be paired in this way, or it can be paired in this way. So this will not give the essential prime implicant. However, this logic level 1, we need to minimize this, and there is only one way to have a group with this. Is it okay? So that will become a essential prime implicant. That grouping of logic level 1s will become essential prime implicant. Please observe here. We can make like this, or we can make like this. Here we can make like this, or we can make like this. Here we have only one way. To minimize the min term of logic present at 6, which is a pair. Is it okay? Yes, sir. So this pair is again become a essential prime implicant. These two are essential prime implicant. However, these two terms are prime implicant. Means if you are getting this term, it cannot be further minimized. Or if you are taking this term, it cannot be further minimized. So these two terms are prime implicant, but they are not essential. These two are prime implicant, but they are not essential. These two are essential prime implicants, which must be in the expression. Is it okay? How many of you now able to understand, beta ji? So the function The minimized expression may or may not be unique. Unique part of the minimized expression are representing EPIs. We have to always observe EPIs first. We have to always observe EPI first. Is it okay? And one more thing, if the SOP is given, go with the SOP. Don't move to the POS. Otherwise, you will not get any of the option present. There is a possibility. Is it okay? So please observe the minimized expressions as well. Higher chances that they are going to create such kind of questions in the MSQ. Multiple select questions. How many of you now able to understand? Beta ji, here D is correct. Both are correct. So just make a simple note point here. In the same question, please write down a note point. K-map always gives the minimized expression. K-map, just write a note point here. K-map always gives minimized expression but the expression may or may not be unique. But the expression may or may not be unique. How many of you able to understand, Beta ji? Please tell me by writing in the comment section. How many of you now able to understand this question perfectly? Please let me by writing the comment section. Now, hoping all of you are able to understand the EPIs, Beta ji. How many of you able to understand this? Okay, great. Once you have all the pairings, need not to take the pair again because already you did the minimization. Is it okay? Yes, sir. Can you tell me one more thing as a case number 2? Please observe. Find the minimal expression. Function of a comma b comma c is given to you as a comma b comma c is given to you as summation of m. Suppose we have a function 1, 3, 6, 7. Can you find the minimized expression for this function, Beta ji? Yes, sir. Now please observe here how to solve the how to get the minimized expression for this function. Please observe, Beta ji. So we have, sir, total 3 variables, 8 possibility, a bar, a, b bar, c bar, b bar, c, b c, b c bar, and 0, 1, 2, 3, 4, 5, 6, and 7. Sir, we are getting output logic 1 onto the binary condition of 1, 3, 6, and 7. Now, can you find the EPIs? First of all, you have to focus on EPIs, essential prime implicant, those groupings of logic level 1s, which can be done in only one way, and it is essential to make that grouping. Only for the logic level 1, not for logic level 0. You must have to follow for logic level 1. Okay. Now, please observe here. So, we have this, sir, and we have this, sir. These two groupings are essential prime implicant. Why? Because at 3 you can make like this as well, at 7 you can make like this as well, and that is a pair only. This is also a pair, this is also a pair. So this pair is essential in order to reduce the min term at logic level 1, at binary of 1, and min term at binary of 6. So these two pairs will become EPIs. And after these two EPIs, since all the ones are already covered, so this will become redundant. This will become redundant, not necessary. And hoping all of you remember the consensus theorem as well. So this will become redundant. Hoping all of you remember the consensus theorem as well. So what is the minimized expression for the function? So minimal expression for the function is a bar c plus of a b. Is it okay? Yes, sir. See, we have a function. If you observe, we have a function 1. 1 means a bar b bar c plus of ab c bar a bar bc plus of ab c bar plus of abc. So basically, if you try to solve this by using Boolean algebra method, A, B, C, if you take common from first and second and this, so you will get A bar, B bar, C plus of from these two, if you take BC common, and from these two, if you take AB common, na? A bar B, AB common, so CC bar will get 0. So this is the expression we are getting, okay? And further, if you observe these two, we can take C A bar, B bar C plus of A bar, one means we have A bar, B bar, C, na? Yes, okay. So instead of going like that, please observe here a smaller one version. Even if we have this pair, then what happened? Sir, function can be represented here as f of a comma b comma c as a bar b plus a b plus bc. So bc is a redundant as per the consensus theorem as well. If you remember the consensus theorem, you will be able to understand. So once the pairing, coding or octating is done, you need not to take the pair, chord or octate again and again. Okay. So this will be your answer, minimized answer. Is it okay? How many of you able to understand, Betaji? Instead of going with a Boolean algebra, we have a Boolean algebra rule as well that shows a redundant term. Hoping all of you remember that. Is it okay? What is the essential prime implicant? Okay, essential prime implicant is those grouping of logic level 1 which contain at least one such min term which is not the part of any other prime implicant. Suppose if we have this one, then this one is only the part of this prime implicant. It is not the part of any other prime implicant. So an essential prime implicant contains at least one min term which is not the part of any other prime implicant. Is it okay? Great. Now, please observe one more question. Can you find the minimized expression for the function shown below? Please observe here. Find the minimized expression from K-map shown below. Suppose we have a 4 cross 4 K-map given. Okay. Now please observe, Betaji, we are on to the very important conclusion. This is your case number 3 as well. Please observe, everyone. This is a special case 3. Case 3, please observe. So we have W bar, X bar, W bar, X, WX, WX bar, Y bar, Z bar, Y bar, Z, YZ, YZ bar. Okay. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. We are having a logic level 1 presented at this position and at this position and at this position and at this position. Okay. So we have to follow the preferences. We have to observe the essential prime implicant and prime implicants. Okay. So if we go with the order of preferences, is there any chord possible? Please tell me the numbers, the grouping of the numbers which can make a chord. Can you see any chord is possible? Yes, sir. There is a chord that 5, 7, 13 and 15 can make. Is it okay? Yes, sir. But I am not going to make that chord. Now, please listen me very carefully. Always first find essential prime implicant along with the preferences. Always first find EPIs along with the preferences. Otherwise, you will do the wrong. Okay. So always find EPIs along with the preferences. Always find EPI along with the preferences. So first of all, I will follow the EPI along with the preferences. Like Octet is making an EPI, CORD made by EPI is formed by having CORD, or EPI formed by pair. First, I will look for the essential prime implicant, and for that, I will find those ones which are somewhere in the odd position. So I found this one to be little bit in an odd position. Okay. Yes, sir. So can you tell me what are the different ways to minimize this min term of logic, min term of 1? What are the ways? There is only one way to minimize min term of 1 is to form a pair. You can't make 3. You can make a pair of 4. You can't make 3 because that is not a cyclic code. Is it okay? So here we have a pair possible, either a pair or a chord or a octet, or a pair of 16 or a group of 16 and 32, so on. Okay, so we have a pair possible. How can we reduce the expression of min term 6? There is only one way, and that one way is to form this pair. So this pair is also EPI, because this pair will have a min term 6, which is the part of only this prime implicant. Prime implicant, that product term obtained from the K-map, which cannot be further minimized. So only this prime implicant, it is not the part of any other. So that represent, this is also a EPI. Is it okay? Only one way, if you observe what are EPI, the pairing, grouping of ones in pair, chord or octet, in only one way, and it is essential to make that grouping, then that grouping will give you EPI. So please observe. Can you observe the logic level present at 11? What are the ways to minimize this? Sir, there is only one way to have this pair. So we must have to take this pair. This pair is EPI. This pair is also EPI. All the pairs are EPI, and first we have to observe EPIs along with the preferences. So since all the pairs are EPIs, and after pairing, chord will become redundant, because already the logic level 1's grouping is done. Mostly student will do mistake first considering the chord, and they will get the answer in the option. There is only one chord, and they will put the answer right. Please first find EPIs. Always first find EPIs, essential prime implicant, along with the preferences. Hoping now all of you able to understand. XZ is the wrong. Okay, there is no XZ in the minimized expression. So what is the minimized expression? Please observe here. The minimized expression is, what is the minimized expression? Someone is saying, sir, the minimized expression is, we have here, we have W bar, and here we have Y bar Z plus of W bar X, and from here we have Y plus of this will give you W Y Z plus of here we have W X Y bar, W X Y bar. Okay, someone is saying, no sir, we must have to consider the pair, the chord as well. Okay, if someone is thinking, sir, this will have one XZ also, XZ also, then you are wrong. Why? Because K-map always gives the minimized expression. K-map always gives the minimized expression. Since here the pairings, all the pairs are EPIs, and after pairing, this chord will become redundant. After pairing, this chord will become redundant. How many of you able to understand EPIs? Someone is saying, sir, big group banana hota hai. Okay, yes. So big group EPIs ka banana hota hai. We must have to form a bigger groups of EPIs, essential prime implicant, first. If there is no EPIs, then we will move towards the orders only. But otherwise, we must have to first follow the higher order of groupings. Is it okay? How many of you now able to understand this, Bitaji? Please let me know by writing in the comment section. Great. How many of you now able to understand this? Please observe One more question. Please observe one more question. Find the minimized expression for f of a, b, c, d as summation of m 0, 1, 4, 0, 1, 0, 1, 2, 4, 5, 6, 7, 8, 10, 11, 8, 10, 11. Please observe this question. 0, 1, 2, 4, 5, 6, 7, 8, 10, 11, 12, 8, 10, 11, 12, 13, 15. Okay. So, can you find the minimized expression for this one, beta ji? See, our first aim is to find the EPIs along with the preferences. Means first EPI with the octet, EPI, then EPI with the chord, then EPI with the pair. So our first aim is to get EPIs, okay? Essential prime implicants. Yes, sir. Our first objective is to identify the EPIs. Please observe everyone, beta ji, this is the most important part and many students will have the confusion in this. So we have A, B, C, D. I am writing here A bar, B bar, A bar, B, A, B, A, B bar. Hoping all of you now able to understand C bar, D bar representation, C bar, D, C, D, C, D bar. So now please observe here, as per the numbering, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. Can you please tell me what are the EPIs? What are the prime implicants, essential prime implicants and implicants? Can anyone tell me about the number of prime implicants, number of essential prime implicants and number of... Is it okay, beta ji? If any doubt, please let me know by writing in the comment section, beta ji. Please let me know by writing in the comment section, beta ji. Hello, hello, hello. Is my audio is okay? Great. Now please observe here. We have a logic level 1 present here and here and here. 4, 5, 6 and 7, 8, 10, 11, 13 and 15. So first of all, you have to tell me, is there any 4 is also there, na? Yes, you can remove 4 if you want, na? Okay, leave it. Whatever it is there, go in the same way. So can you please tell me how to move, whether we have to first create an octet, pair, chord, and we have to observe the essential prime implicant. First aim is to find the EPIs, okay? So find the maximum coverage of logic level 1 in which at least one prime implicant, at least one minterm is such that it is not the part of any other prime implicant, okay? So if we observe this logic level 0, logic level at 0 is 1. So sir, there is no octet possible, but there are two chords are possible. We can make either this chord, or we can make this chord. So we can't say which one is the EPI. There is no EPI in this. If we observe this logic level 1, then we have only one way, this chord. There is no other way to minimize this logic level 1. So this logic level at 1 indicates this is a EPI. How many of you now able to understand? How many of you now able to understand, beta ji? Yes, sir. So because of the logic level present at 1, this chord will become EPI, essential prime implicant, because this one is only the part of this chord. It is not going to be part of any other chord. Now come to the next one. If you observe this one, then we have only one chord possible, and that decides again EPI, that decide again EPI, this chord must be needed. Why? Because there is no other way, to minimize that particular logic level at 2. Is it okay, beta ji? So this chord is essential, as well as this chord is also becoming essential, because the binary present at 2. Sir, no, you are writing wrong. Okay, I am writing wrong. Why? Because the binary present at 2, please observe, I've just tried to show you, because the binary present at 2 can have the chord like this, or it can have the chord like this as well, sir. So, sir, there are two possibilities. It can have the chord like this, sir. Yes. So I can't say which one is we have to take. It will not decide it. Now please observe here. Here we have either this chord or this chord. So there are two possibilities. We can't proceed. Now come to the next one. This one. If we observe this one, then we have only one chord possible. In order to minimize this one, we have only one chord possible. This one. Is it okay? This is again a EPI now. This is the way we can approach to the solution. Is it okay? It is not like just taking the groupings. Now this group is, must have to take this group, because this is a EPI. The logic present at 13, the min term of 13 can be minimized. Maximum it can be minimized by a chord, and there is only one way to minimize this, to take this chord, center chord. So now this center chord will be essential. With this we can't reach, because it can be done with this as well as it can be done with this. With this we can't reach, because it can be done like this, or it can be done like 2, 6 and 0, 4. How many of you now able to understand, beta ji? In the same way, please observe the next one. How we can do the minimization of this one? There are two possibilities. Either it can be done with this chord, or it can be done with this chord. So leave it. Move to the next part. Please observe this one. How we can do the minimization of this one? This one can be minimized by the pair, either with this pair or with this pair. So there are two pairs possible. Again, leave it. Come to this one. This one can be minimized in only one way. What is the way possible? That this chord. So we must have to take this chord as well. So these three will become EPIs. How many of you now able to understand, beta ji? Sir, 0426 ka group. 0426. I am saying that if you are going to make 0426 group, then also 4, 5, 6, 7 group is also possible to minimize the logic level present at 6. We have to identify those groups which can be formed in only one way. Now please observe, what is an essential prime implicant? An essential prime implicant contains at least one min term which is not the part of any other prime implicant. So if you observe, this one is not the part of any other prime implicant. In the same way, if you observe, this one is not the part of any other prime implicant. If in the same way, if you observe this one, this group is only possible. It is not the part of any other prime implicant. How many of you now able to understand, beta ji? Great. So this question will have multiple solutions possible. First, the corner groupings. Corner groupings are B bar and D bar. So we have B bar, D bar from the corner grouping, and we have this. So this will give you A bar, C bar, C bar first 4, and center will give you BD. Is it okay? These three are the EPIs. Please observe, beta ji, this question is very good question. Please observe everyone. So this is the essential prime implicant. Now, next, K map always gives the minimized expression, but the expression may or may not be unique. Now, one can take either this as a chord. Is it okay? So one can take this as a chord. One can take this as a chord and this as a pair. So let's have this as a chord and this as a pair. Is it okay? Because the chord is not possible. So this as a chord and this as a pair. So we have one expression possible, A bar B plus of A B bar C. Another possibility, With the same, one can say another possibility, sir, we can take this and this pair. So we can take this and this pair. So if we take this pair, then it will become, if we can take this pair, then it will become ACD. ACD. One can say, sir, we have one more possibility. We have one more possibility. Please observe, beta ji. One can say, sir, we have one more possibility. And that possibility is, instead of taking this chord, why you are not taking this chord? Okay, we can take this chord as well. We can take this chord as well. Okay, so if we are going to take this chord and this pair, then we have one more possibility. K-map gives the minimized expression, but the expression may or may not be unique. So we have A bar and we have D bar, A bar, D bar. Is it okay? Yes, sir. Someone can say, sir, we have one more possibility. Why you are not considering this? Why you are not considering this chord and this pair? Yes, this is also possible. So if we are considering this chord and this pair, then we have total 4. And actually, all of the above are minimized expression only. Here, if you observe, these are the essential prime implicants. If you observe, these are the essential prime implicants, which must be the part of minimized expression. Rest, if you observe, we have B, A bar B, which cannot be further minimized. It is a prime implicant, but not an essential prime implicant. A, C, D, it is a prime implicant, but not essential prime implicant. Hoping this question makes you very comfortable to this particular topic. How many of you now able to understand, beta ji? Great. How many of you now able to understand? Always first find EPIs along with the preferences. First find EPIs along with the preferences. Can you please tell me? Find EPI from K-map shown below. You have to follow the same EPI rule for the POS as well, but always remember EPIs are defined for the product term, not for the SOP term. But we will follow the same rule. First we find those logic zeros which are somewhere apart, then we will follow the pairing, coding or octating accordingly. Is it okay? Great. So can you please tell me the EPIs from the K-map, beta ji? Can you please tell me the EPIs from the K-map, beta ji? Please forgive me for my writing because I am just wanted to cover more and more topic today. So I am moving little bit faster. 0 0 0 1 1 0 1 1 0 0 0 0 1 1 1 1 0. Can you please find the EPIs from the K-map shown below? Can you please tell me what are the EPIs from the K-map shown below? 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. You can't do the minimization without identifying the EPIs. Can you find the EPIs now? Sir, gate CS ke liye? Yes, beta ji, this is for every branch. Can you find out the EPIs now? Yes, sir. See, those logic level ones which can be the part of only one pair, chord or octet, largest group. Is it okay? So if you observe this logic level 1, it can be minimized in only one way, and that one way possible is this. So this will give you a EPI. So EPI, yes sir, this will give you a EPI. EPI, sir, we have, if you observe here 0 0 0 0 0 0 means X bar, and from the last we have possible 0 0, that is Z bar. So X bar Z bar is a EPI. And if you observe this logic at 5, so the min term at 5 can be minimized in only one way, by having this chord. Okay, yes sir. So this is also your EPI. Yes sir. Any other EPI? Sir, can't we say this to be the EPI? No. Why? Because this logic level at 3 and 11 can be covered through this, or it can be covered in this way, because K-map is joined from top to bottom. Both are forming a chord, and in both 11 and 3 are in the groups. So they are not essential prime implicant. They are prime implicant, but not essential prime implicant. Is it okay? Whenever more than one, whenever there are non-essential prime implicants present, always the K-map will give the minimized expression, which is not unique. More than one solution is possible. How many of you now able to understand? Please let me know by writing in the comment section, beta ji. Up to this part, everything is clear? All of you able to understand in a well way? Are please tell me, beta ji, all of you able to understand up to this part? Great, sir. Now, let me move towards I am giving you one question as a homework to all of you. So this is your homework question. Okay, you have to find the essential prime implicant. Now please observe, please observe, please observe. Can you please tell me the minimized expression for the function f of a, b, c, d as pi of m 0, 1, 2, 0, 1, 2, 4, 6, 7, 8, 9, 10, 11, 12, 15, 11, 12, 14, 9, 10, 11, 12, 14, 13, 14. Can you tell me the minimized expression for this function, beta ji? This is in POS, so you must have to go in POS only. Okay. But in POS as well, whenever you are solving, first of all, you have to identify in the same way those groupings which contains at least one zero, which is required to be the part of the group, and in only one way it can be grouped. Okay. So we have A plus B, because it is 0, 0. We can represent like 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. So you can represent like A plus B bar, A bar plus B bar, A bar plus B, C plus D bar, C bar plus D bar. In POS, logic level 1 is represented by complement variable complement, and logic level 0 will represent by variable. Okay. Yes, sir. And we know about the numbering as well. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. What are the positions where logic level 1 is present? So we have a 0, 1, 2, sorry, sir, 0. Logic level zeros are present at 0, 1, 2, 4, 6, 7, 8, 9, 10, 11, 12, 13, and 14. So first of all, you have to identify, is there any octet possible? So your first approach is to identify the octet. Yes, sir, octet is possible. So if octet is possible, the largest grouping, and it can be created in only one way. Is it okay? Yes, sir. So what this octet will give? What this octet will give? An octet can eliminate 3 variables. So this octet will give you, from here we have D and D. So in the entire we have only D. Okay. Yes, sir. Dot. Because POS, product of sums. So we have one sum term, minimized sum term. Now next, minimized sum term. Is there any chord possible? Yes, sir. A chord is possible. This chord. So what this chord will give? What this chord will give? Sir, this chord will give you A bar plus B. So we are having A bar plus B. How many of you able to understand, beta ji? Next, we will get POS, product of sums, minimized POS form. Sir, another chord is possible. Which chord? Sir, another chord is possible. This chord is possible. This chord is possible. So this chord will give you, from here we have A bar and from here we have C. So A bar plus C. Then sir, we have logic level 0 here and logic level 0 here. One more chord is possible. Which chord, beta ji? So sir, this chord is possible. Okay. So this chord will give you the top and bottom 8901. This chord will give you, sir, from here we have B and from here we have C. So B plus C. Great. And the last, sir, we have one this. What can we do with this? We have only one possibility to have one pair. And this pair will give you, from here we have A bar, from here we have A plus B bar, and from here we have C bar. So this is the minimized POS expression obtained from the K-map. Is it okay? They may give you in the form of SOP. So you have to observe the result. Do not open this to find the minimized SOP. To find the minimized SOP, those places where logic 0 is not present, you can just put logic level 1 and find out the min term. Is it okay? That is the best way to find the minimized expression. Always remember, K-map always gives the minimized expression, but the expression may or may not be unique. Is it okay, beta ji? No, here we don't have, here we don't have EPIs, beta ji. Here we have a EPIs. I have asked in this 3 and 11. Beta ji, actually there are two ways. If you observe this, someone is asking for this. Let me tell you once again. See, you can make this chord like this, that includes 11 and 3. Or someone can make chord like this. So both are the possibility. If more than one way is possible to make groups, it means in this prime implicant, this 11 and 1 is the part. However, in this prime implicant also 11 and 1 is the part. No one is such that it is not the part of any other prime implicant. Is it okay? So that is only when we have only one way to form a grouping. If we have only one way to form a grouping and grouping is an essential, then only it gives the essential prime implicant. Is it okay, beta ji? Now this is the till now we have understand how to find the minimized expression from the K-map, basic. Now let's talk about don't care. Very important, very important portion for the gate or ESC. Don't care. Okay, I will show you one question as well. Today we are going to design one combinational circuit by using K-map. Okay, great. So please observe here concept of don't care. Don't care is represented by the cross symbol. That is don't care. Don't care can be logic 0 or logic 1 depending upon our requirement and our requirement, okay, depending upon our requirement. Basically, there are certain set of combinations of the input which are never going to appear. For such combination of input, we consider, for such combination of input which is never going to be appear, for such combinations we will consider the output to be either 0 or 1, because ultimately if such input is never going to be appear, then its output will have no sense. So we can just consider it as logic level 0 or 1. But one thing is very important. In K-map, when we talk about K-map, in K-map, the logic of don't care must be selected such that it helps in minimizing the logical expression. It is okay. Don't care may be logic 0 or 1 depending upon our requirement, but our requirement in K-map is to get the minimized expression. So we always select the logic of don't care such that it helps in minimizing the logical expression. For example, suppose we have a function, find minimized expression, find minimized expression f of a comma b comma a comma b as summation of m 0 comma 3 plus don't care. Don't care is represented with this plus symbol. It can be represented plus, then either in D, either in capital D, either in this format. Okay, so all are don't care. If you have a function in minterm plus anything, that is a don't care. So this don't care at 2. Is it okay? So it means the input condition of 1, 0 is never going to be appear on the circuit. So for that condition, the output can be considered as logic level 0 or 1 because that condition is never going to be appear in the circuit. Okay, yes sir. Now please observe here. Sir, how to find the minimized expression? So if you observe, we have a and B. We have a and B. So it's a SOP representation. So I'm writing A bar A, B bar B, and we have 0, 1, 2, 3. Now where we are having logic level 1 present, we are getting logic level 1 on 0, 0, and we are getting logic level 1 on 1, 1, binary of 0 and binary of 3. What is the logic level at 2? Don't care. What is the logic level at 2? Don't care. It means the input, a binary condition 1, 0 is never going to be appear onto the system. For that, output can be considered either 0 or 1. It's up to you because that condition is never going to be appear on the system. But when we talk about K-map, the logic of don't care is fixed. If we have to find the minimized expression for this function, then don't care can be logic 0 or 1 depending upon our requirement, and our requirement in K-map is to minimize the logical expression. So we always select the logic of don't care such that it helps in minimizing the logical expression. If you observe, if we consider this as logic level 1, then we can make two pairs. If we consider it logic level 1, then we can make two pairs. And these two pairs will give the information of A plus B bar. If someone is saying, sir, it's up to me, I can consider it logic 0. So if someone wants to consider it logic 0, then what happened? If someone is saying, sir, I will consider it as logic 0, then if you consider it as logic 0, then what happened? Then sir, alone will created A bar B bar plus of AB. Now which one is more minimized? Absolutely this one is more minimized. This is the wrong one. So you must have to choose the logic of don't care such that it helps in minimizing the logical expression in K-map. Always remember, don't care can be logic 0 or 1 depending upon our requirement, but our requirement in K-map is fixed to get the minimized expression. So we always select the logic of don't care such that it helps in minimizing the logical expression. Is it okay, beta ji? How many of you able to understand? Overlapping? No, not overlapping is not allowed. How many of you able to understand this? Great. Now please observe, beta ji, one more question. Suppose if we have a function of A comma B, just I want to, from all of you, you have to comment on the in the comment section what must be the logic of don't cares. Okay, so we have 0 1, we have 0 1 0 1 6 7 plus don't care on 3 and 5. So can you tell me what will be the what will be the logic of don't care we have to consider? For solving this, we have A, B, C, A bar. It can be clearly observed, sir. We have A bar A, B bar C bar, B bar C, B C, B C bar, and 0, 1, 2, 3, 4, 5, 6, and 7. So where we are getting output logic 1, we are getting 0, 1 at 6 and 7. 3 and 5 are don't care. So can you please tell me what should be the logic of 3 and 5? What should be the logic of don't care here? What you will consider the logic of don't care? Someone is saying, sir, if we consider the logic of don't care as logic level 1, we have a chord possible, which will be a higher preference than pair. Is it okay? Yes, sir. But at the same time, But at the same time, I started finding out the EPIs, essential prime implicants. Essential prime implicants are not covering that, don't care. Okay. So only the groupings of logic level ones. So I started finding out first those min terms which can be grouped only in one way. Those logic level ones which can be grouped only in one way. So when I saw that, we all can see 0 and 1 must need to be grouped in order to have the min term of 0, in order to reduce min term of 0. In the same way, in order to reduce min term of 6, this pair is EPI. And now you can see, if you are going to consider these two as logic level 1, one more term get added. So function will not get minimized. It will be better to have these don't care considered as logic level 0. Is it okay? Because if you consider them as logic level 0, then your answer will be more minimized. So don't care may be logic 0 or 1 depending upon our requirement. And our requirement in K-map is to get the minimized expression. Always remember, our prime objective in K-map is to get the minimized expression. If someone consider them as logic level 1, one more term get introduced. So this is not more minimized, this is more minimized. Is it okay? So we must have to choose. We always have to choose the logic of don't care such that it helps in minimizing the logical expression. We don't have to make the groups. We have to find the minimized logical expression. The logic of don't care must be such that it helps in minimizing the logical expression. Hoping now all of you able to understand this concept perfectly, beta ji. Please let me know by writing in the comment section. Please let me know by writing in the comment section. If there is any doubt, please let me know by writing in the comment section, beta ji. If there is any doubt, please let me know by writing in the comment section, beta ji. Great. So beta ji, someone is asking that he is in final year and want 50 plus marks in GATE. See, the first thing you have to observe what are the different concepts and how to solve the questions based on those concepts. Like in today's class, you will be able to understand that we have discussed K-map, but not only discussed K-map. What is the K-map? Why we are using K-map for the minimization? How we are doing the minimization? And what are the special cases? These 4 things are very important. If someone is just able to understand to make the groups and don't know about the EPIs, can't do anything in GATE. Is it okay? So you must have to understand, and for that it's my advice to you that if you have already studied for GATE, then okay, you can go with the revision considering these points. Otherwise, it would be far better to go with some paid course, because there you will get structured things and the important things will be highlighted, so you can easily understand the concept behind that, which is actually going to be asked in GATE. Okay. Beta ji, always remember, K-map always gives the minimized expression. K-map always gives the minimized expression, but the expression may or may not be unique. If you go through the topics now, I have shown to you all of the things. See, the overlapping is allowed, but the purposeful overlapping. Na? Here this one is the part of this group as well as the part of this group. But we are observing we have to make all the ones in some groups. Okay. And first we have to find the unique groups, that is called as essential prime implicant for logic level ones. The grouping of logic level ones. Can you find for this? We have a pi of m 0, 2, 4, 1, 3, 5, 6, 7. The max term of the expression will be. See, this is also very important. Please observe, beta ji. Please observe, beta ji. So we have a bar A, B bar, Okay, it's in a POS, 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 POS. A bar, B plus C bar, B bar plus C bar, B bar plus C. 0, 1, 2, 3, 4, 5, 6, 7. So you can observe here we have 0 at 0, 2 and 4, and rest everywhere we have don't care. Betaji, the first preference is given to an octet. So if we select all the logics of the don't care as logic level 0, we have an octet. Is it okay? Which has the highest preference. And what is the minimized expression? 0. Logic 0 and logic 1 is also a logical expression. Is it okay? So if the entire entry is filled by either 1, then we will get 1. If it is filled by 0, we will get 0. Is it okay? Logic level 1 and logic level 0 is also representing a logical expression. These are also a logical expression. How many of you able to understand? Please let me know by writing the comment section. So beta, if you have a Parakram batch, just follow the Parakram batch. Go through the lectures. Okay, that's all you have to do. And if possible that you have a Khajana access also, you can increase your speed as well. Your learning speed by having 2 subjects at a time. Okay. How many of you now able to understand the K map, beta ji? Please let me know by writing in the comment section. How many of you able to understand the K map? Please let me know by writing in the comment section. Please let me know by writing in the comment section. How many of you able to understand K map? Please let me know by writing in the comment section. How many of you able to understand K map? Please let me know by writing in the comment section. How many of you able to understand K map? Please let me know by writing in the comment section, beta ji. Is there any doubt up to this part? Okay. So, is there any doubt up to this part, beta ji? Please let me know by writing in the comment section. Is there any doubt up to this part? Is there any doubt up to this part? Great. So I just want to conclude this topic. With one question asked in Indian Administrative Services. Let's conclude the topic with one question that asked in Indian Administrative Services. So now how to utilize this minimization and how to design any combinational circuit. Whatever we are studying is the purpose is to design our desired circuits. We can design our desired circuit. Okay, K-map is just a tool which helps us to the minimization of the logical functions only. That gives the liberty to us so that we can have a minimization of the logical expression only. Is it okay? That's all that can be held by the K-map. Okay. So please observe this question. A farmer has 2 sheds. N1 and S1. And in his farm, to keep produced and belongings, he keeps vegetable V as a farm produce and a goat G which can eat the vegetables and a dog that can bite a goat in the absence of the farmer. So the farmer alone has to manage both the sheds. Without losing either vegetables or the goat. Okay. Suggest a logic circuit that can alarm him under any catastrophic condition by means of a buzzer. Under any catastrophic condition by means of a buzzer. How many of you able to understand the question? How many of you able to understand this question? Please let me know. By today only we are going to design this. Okay, great. I just want everyone to have a think on this, okay? How many of you able to understand this question now? Okay, great. Let's try to solve this. So we have to design a logic circuit for the farmer, okay? So we have two sheds, and we have three variables. Let V, G and D as variables. Variables means we have vegetable, goat and dog. These three are said to be a variables. Now hoping you are able to understand what is A, B, C, what is A, B, C, D and all with the help of this question. So vegetable, goat and dog, I am considering these three parameters are as a variables, okay? So we have vegetable, farmer, vegetable as a farm produce, goat as a farm produce and D, dog as a protector of the farm. So we are considering these three as a variables, okay? Now we have two sheds N1 and N1, N1 and S1. We have two sheds, shed N1 and shed S1. So we have shed N1 and shed S1, okay? Consider if variables are in shed N1, then they are represented as logic 1, okay? And if variables are in shed S1, then they are represented as logic 0. So if I am saying vegetable V as logic 0, it means vegetable V is present in shed S1. If I am saying vegetable V is logic 1, it means vegetable V is in shed N1. Is it okay? That is how I am just defining the logic 0 and 1 for the two sheds S1 and N1. Is it okay? Yes, sir. We have to design a buzzer, and the buzzer will buzz only when the catastrophic condition will came, like when the dog bites the goat or the goat eats the vegetables, okay? Any such condition happened, then the buzzer will get on, okay? So we can define the circuit, buzzer circuit, okay? We can define the buzzer circuit. Output as Y, okay? Y is 1 means buzzer is on, and output Y is equals to 0 means buzzer is off, okay? So Y is equals to 1. You can say, sir, just represent Y only, okay? So Y is equals to 1 is indicating buzzer is on, and Y is equals to 0 is indicating buzzer is off, and we have 3 input. So we have vegetable, goat and dog, and we have two sheds N1 and S1. We have two sheds N1 and S1, okay? Hoping now all of you able to understand, okay? Yes, sir. Now for any catastrophic condition, the buzzer is on, and whenever output Y is equals to 1, it indicates buzzer is on. So please observe, to design any to design any logic circuit, first of all we have to understand the inputs and outputs. So we have inputs and outputs. Inputs we have vegetable, goat and dog, and output is the buzzer sound. Is it okay? Yes sir. Whether the alarm is on or the alarm, it is alarming or not alarming only. So maybe all the three are present in shade S1. Maybe any one of them is present in shade N1. Any one of them is present in shade N1. Any two of them are present in shade N1 and one is present in shade N2. Okay. So 1 0 0, 1 0 1, 1 1, 0 and 111. How many of you able to understand up to this part? Please let me know by writing in the comment section. Okay. Can you please tell me, beta ji, how many of you able to understand up to this part? 0, 1, 2, 3, 4, 5, 6 and 7. If you are able to understand, must need to put the like button on. Okay. Okay, great. So just 2 minutes. Just let me finish it. So now you know what is A, B, C, D in the different expressions. Now you know what is A, B, C, D in the different expressions, how we used to design any digital circuitries. Is it okay? Yes, sir. And see, whenever goat and vegetable are in the same shed, whenever goat or vegetable are in the same shed, dog is also in the same set. So dog bite goat and goat eat vegetables. So yes, alarming is needed. So alarm on, it means buzzer on, and you can say output y is equals to 1. If goat and vegetables are in the same shed, then also alarm need to be on. However, if vegetable and dog are in the same and goat is in the different shed, no need of alarming. In case of goat and dog are in same shed, then dog bites goat. So definitely alarm is needed. Here alarm is needed. No, sir, goat and dog are in the same shed. Alarm is needed. Sir, here dog and vegetable are in the same shed N1. Goat is in shed S1. So no alarm is needed. Here goat and vegetable are in the same shed. Alarm is needed. Alarm is needed. Is it okay? Yes, sir. So now we have the output y to be high or onto the binary condition of 0, 1, 2, 3, 4, 5, 6, 7. So we want to design a digital circuit. We want to design a digital circuit which will have an output function in terms of V, G, D, where V is a MSB and D is a LSB, as a binary of 0, 1, 0, 1, 3, 4, 0, 1, 3, 0, 1, 3, 4, 6 and 7, 6 and 7. So before implementing the circuit, it would be better to minimize the logical expression. So how to minimize the logical expression? Very important. Always before implementing any logic circuit, we must need to do the minimization. So we have V, V bar V, G bar, D bar, G bar, D, GD and GD bar. So numbering, we have numbering as 0, 1, 2, 3, 4, 5, 6 and 7. Okay. Yes, sir. Now we have logic level 0, 1, 3, 4, 6 and 7. 0, 1, 3, 4, 6, 7. So you can observe how to do the minimization. To do the minimization, first of all, we have to identify the EPIs, and if you observe, this one can be done with this as well as the corner ones. This one can be done with this as well as with this. This one can be done with this as well as this. So how we can start? Great. So there is no essential prime implicant that I can see. Any one of you can see the essential prime implicant, beta ji? 0, 1, 0, 1, 3, 7, 0, 1, 3, 7, 6, 4. So how we can go with the essential prime implicants here? So sir, there is no, there is a multiple possibilities. So how we can proceed? How many of you able to understand the difficulty? Because there is no essential prime implicant. All ones can be the part of another as well. All ones can be the part of another as well. So what we can do, we can consider any one solution. So let's take this solution. We can consider this. You can consider this. However, there are multiple solutions possible. You can consider this. Is it okay? If someone wants to consider this, and consider this, then that is also correct. Is it okay? There is no API in this because everyone can be the part of another prime implicant possible. Is it okay? Yes, sir. Now please observe here. Now please observe here. How to implement this? We have the logical expression for the function y minimized as sir g bar d bar plus of, we have sir v bar d and vg. Is it okay? Next, we have observed the different logic gates as well. So we have observed the different logic gate as well. This is a NOR gate, g bar d bar is a NOR gate. So you can represent g bar and d bar. Okay. So this is your g bar plus d whole bar, that can be represented as g bar d bar. Okay. And we have, sir, g bar d bar and v bar d can be represented as v bar. Okay. And g d v. So v bar d, and the last one we have vg. So the last one we have v and g. How many of you able to understand beta ji? vg. So we need to pass it through the OR gate. If only 2 input OR gate, we need to use 2 input OR gate. Otherwise, you can implement the buzzer like this. So if you want to design the circuit, it can be designed like this. Now, either you can use camera to detect a dog, goat and vegetables, or you can put the sensors, okay, to identify that which of them are in shed 1 and shed 2. Is it okay? So this is your buzzer circuit that you want. How many of you able to understand the entire process of minimization and implementation and use of the K-map, as well as implementation of any circuitry, any combinational circuits? So this you can just give to the your farmer. He will be very happy. How many of you now able to understand beta ji? So great. Hoping you are able to understand the K-map in a well manner. The conclusion is always first find EPIs along with the preferences. Don't care. You have to select the logic of don't care such that it helps in minimizing the logical expression. In the same K-map, some of the don't cares may be logic 0 and some of the don't cares may be logic 1. Is it okay? There is no issue. You can take the don't cares as logic 0 or logic 1. Ultimately, they will help to minimize your logical, minimize the logical expression in K-map. Is it okay? Great. Hoping all of you able to understand this question in a well way, beta ji. Okay. I am giving one more question to all of you as a homework. Please try this one. And in the upcoming class, I'm again going to discuss some important part of the XOR gate. Later on, we will move towards the combinational circuit. Please let me know by writing in the comment section. Will all of you able to understand the gray code, K-map and all the conditions of the K-map? Up to 4 variables, I think all of you able to understand how to solve the questions. Maximum times the question asked up to 4 variables. Only 1 or 2 times 5 or 6 variable, and that 5 and 6 variable we will consider in the mixed topic. Is it okay? At the last, we will consider the mixed topic. Great, great. So now you can solve any question. It doesn't matter for minimization. The minimization part, you can solve any question of the minimization part. You can solve any question of the minimization part. Best is to go with the K-map. Prefer to go with the K-map. Is it okay? Great. So thank you everyone. Lots of love. Good night.